Hello, welcome back everyone to our subject, Principles of Steel Design. And for this session, we will be discussing the introduction of our first component, which is yung tension members. And then we will also distinguish what is the difference between gross and net area. So before we can actually calculate kasi yung value of the capacity of our tension members, we need to be aware what particular area we need to consider in calculating our capacities, right? So, this session, ito yung magiging outline niya. We have uh, yung differentiate natin, yung gross and net section. And then we discuss yung mga limit state for tensile strength ng tension members. And then we will solve some examples calculating the gross area and also the net area of our section. Okay, so main goal or outcome natin after this lecture are as follows. You differentiate gross and net sections to outline the limit state affecting tension members. And then lastly, to calculate gross and net areas of a given tension member. Okay, to start, let us recall the previous module that we have regarding design philosophies. So as we said, design philosophy is the one who decide what will be the direction of our uh, design or how we calculate things. So design philosophy influences yung consideration natin on how we detail our structure. And when we select a particular design philosophy, we encounter a limit state. So limit state, as we have also defined before, are specific condition or state na nasa subject yung structure natin, but ang goal is not to attain those limit kasi as the term suggests limit, it means once this value or this particular limit state is exceeded, it means hindi na magiging functional or yung full capacity of our structure uh, is diminished na. So yung kanyang safety, functionality, and serviceability will be in question na. Okay? Then we have two types of limit state. As we mentioned, we have ultimate limit state and serviceability limit state. When we talk about ultimate limit state, we said that this limit state talks about all of the extreme conditions that may happen on our structure, may be subjected to earthquake, to very strong storms or typhoons. For the case of highway or bridges, yung overloading of vehicles. Okay, so basically we are trying to calculate the worst case scenario if ever this phenomena happen on our structure. And under ultimate limit state is what we call yung strength limit state, wherein strength limit state is more specific in nature. So since our subject deals with the components of our structure, magiging limit state natin under ultimate limit state will be strength limit state kasi we will be focusing on the design or analysis of each structural component, and then we will determine what specific limit state or strength limit state is applicable for each of this component. And then another category of limit state is what we call serviceability limit state that we have mentioned before, deals with the overall occupancy of our structure. It means it may be the limit of deflection or cracking or vibration that our structure can withstand, and we don't want this to be exceeded also. So this limit state again are part of the design philosophies that we selected, and we hope will not be exceeded in any form so that our structure will remain its capacity or will fulfill its intended purpose. Also, we also mentioned that in steel design, we are using three approaches or three design philosophies, and two of these will be used throughout this course: the allowable strength design and the load and resistance factor this time. And then for plastic design, we will maybe tackle that on the later part if time permit us to. Okay, but again, the focus for now will be ASD and LRFD. We also defined last time the difference between LRFD and ASD. So for LRFD, it uses factors on both sides of the equation, meaning on the required strength side and the design strength side. LRFD uses a multiplier to adjust yung mga values natin. For the loading side, or do sa required strength side natin, we are multiplying yung load effect natin by a load factor na sabi natin typically greater than 1 yung value kasi we intend to amplify the effect of these loadings. And then we try to consider what particular loadings are present in the structure, then try to sum it up to get the most critical effect that we have dun sa structure natin. And then this critical effect na ma-identify natin based from the loadings should be less than or equal dun sa design strength natin, dun sa capacity ng section natin. And when we look at the capacity of the section, let's say Rn, it is also being multiplied by a factor phi. Ang tawag natin is resistance factor. Na ang factor niya is less than 1.0. So, ibig sabihin, nire-reduce pa natin yung actual or yung nominal capacity niya. So, when reduce, ibig sabihin, we are trying to account for any human error, uncertainties na pwedeng mangyari during the fabrication of the actual members. Let's say, hindi masyado skilled yung nag-connect o nag-weld nung mismong member mo sa another member. So, the transfer of loading may be not totally 100% transferred to the other members. So, that is the purpose of using resistance factor. So, again, we also discussed the load combination. So this is a simplified version that will be used all throughout this course. So as you can see here, almost all of the factors are more than one. And that is because we are trying to amplify or to account for overloading in the future. But as you can see, some factors are less than 1.0. It means na during this combo or in using this combo, not all the time or almost all the time, uh, this combination will be 100% present in the lifetime of the structure. Maybe only half of its lifetime lang siya magagamit. Kaya sabi ni code, let us reduce is 2.5. So same reason applies with the other factor na less than 1, except yung dito sa 0.9 dito, no? So yung dead load dito, as we discussed last time, is to account for any returning moment that is present sa structure natin. Parang when our structure is subjected to lateral forces, either wind or earthquake, so it may be subjected to overturning moment. But for our structure to retain its stability, maybe, or the code assumes that maybe 10% of the loading or the dead load is contributing to retain yung stability ng structure natin. Kaya sabi niya, 10% is considered for that. Kaya 0.9 lang yung gagamitin natin. So that is for LRFD load combo. And then we have yung ASD. Again, sa ASD, almost the same formula. But as you can see here, do sa loading side, do sa left side ng equation natin, there is no factor. Kasi yun po yung feature ni ASD. It is, ina-assume niya na the calculated service load on your structure is as is siya nandun. Or kung ano yung value niya, yun na yung gagamitin for design. So, yung adjustment happens dun sa right side of the equation, which is dun sa capacity natin. They are dividing it by a safety factor that ang value niya is greater than 1. So, ang purpose is also to reduce the value of our capacity. So, again, for human error and uncertainties. Kaya, yun yung inaano ni code. Okay? Or nung philosophy na to. And then we also are using some load combination to consider the most critical effect that may happen on the structure. And apparent also are factors less than 1. It means na maybe this load combo will not happen all the time dun sa structure. Kaya kinukonsider niya na point or less 25% yung kanyang capacity. And then as you can see here for the earthquake, naging 0.7 yung factor kasi using the earthquake equations to calculate the seismic forces or base shears dun sa structure natin, it is based on LRFD approach. Kaya sabi ni code to accommodate the factors that were used for the LRFD equations in calculating for the seismic forces, we reduce it by 30% to consider or to assume that it is under ASD load combo. So, kaya ganun po yung nangyari dito. Kaya naging 0.7. And then, same reason yung nag-apply dun sa other factors as mentioned dun sa LRFD natin. Okay? So, yan yung basic knowledge natin about previous lecture natin. So now, let us recall a bar or a plate for that matter. Let's say we have a material that then we subject it to an axial force P. Okay, so during our mechanics of deformable bodies, we know that when we subject this material or this object into a tensile force or an axial force for that matter, the material experiences stress. And as mentioned, we consider this stress using the formula load over area or P over A, wherein the actual load is the one applied on our structure, and then the area or the cross-sectional area is actually the what type of area. So if ever this is our three-dimensional POV of the bar, so let's say this is the applied loading P. So the area we are talking about is actually the cross-sectional area or the perpendicular area dun sa loading natin. So dapat perpendicular siya, okay, for us to consider na dun sa stress natin. Kasi itong normal stress na tinutukoy natin dito, ay yung gagamitin natin, is a normal stress. Okay? Type of stress. Kaya dapat perpendicular yung loading natin dun sa plane ng area natin. Okay? So, yun yung dapat tandaan natin. Now, let us consider a tension member for us to distinguish kung ano tinatawag natin gross and net section. So, let's say we have a truss. So, let's say this is a truss. Okay? May mga following members siya. So, we have yung kanyang supports. Okay? Then, let's say you analyze it. You calculated the member forces using either joint method or method of section. And then, let's say we isolate this part. Okay? Then that part is this part. Okay? So let's say that member is a tension member. So as you can see, yung tension member, ganito yung itsura niya on site. Then as you can see at the end of this member, we can see holes on it. So yung holes na yun, basically, is used para ipasok yung bolt natin, para i-connect yung member natin to another member in the truss na i-construct natin. So, basically, kung ito yung tinutukoy nating member na yon, so para ma-connect siya dun sa top chord natin and also dun sa bottom chord natin and also in this member natin sa gitna. Okay? So, they're using a bolt connection, kaya may butas yung section natin. So, when we are talking about tension members, so kailangan natin makuha yung area na magre-resist nung load due to tension. Okay? So, kapag titingnan natin tong member na to, we have two sections actually. Yung gross section na tinatawag natin ito, and then yung net section. So, gross meaning, ito yung main body ng tension member natin. Yung buo pa, yung mismong section natin. Kasi kailangan nga natin is cross-sectional area, di ba? Or yung perpendicular na area. So, once na dinrawing natin to, this can be the drawing na nung halimbawa nung plate na sinection natin. Okay? And then this is the applied loading. So yung area na yun is this area. Okay? So yan yung kailangan natin. So that is our gross section. So yung section na yan, meron siyang lapad or width. Okay? And also meron siyang height na tinatawag natin thickness. Okay? So when dealing with gross sections, we can calculate yung tinatawag natin gross area. And according to our definition here, gross area or AG of a member is the total cross-sectional area of the section. So, ibig sabihin, kukunin lang natin yung area nito. And when we look at this plate, for this matter, yung itsura niya is a rectangular, we know that ang area ng rectangle is base times height. So, to get the gross area for this section, that is just base times height or W times yung thickness natin. So that is the case for plate or kapag rectangular yung section. If our section is different, so let's say W-shaped section siya, S-shaped section, C-section, or any rolled sections na diniscuss natin before, yung AG will be taken or AG is pupunta ka sa table of sections natin or table of shapes. Kapag tingnan natin yung table of shapes, meron dun column for AG or area. So yun yung gagamitin natin. Again, this formula is for plates only. Okay, or kapag rectangular yung cross section natin. And then we also have another area kasi lahat ng portion na to are gross sections, ano? Or nag-exist yung gross area. Ngayon pupunta tayo dun sa net section naman. So sa next section, since kailangan natin is perpendicular dito sa loading natin, ito yung perpendicular na section. And yan section na yan, kaya tinawag na net section, pero siyang butas. Okay? So, kung may butas siya, ano nang nangyayari sa area natin? Nababawasan yung area natin. Okay? So, kaya kapag sinabing net area ang hahanapin natin, it is the sum of the product ng thickness and the width of each element natin. So, since nagbawas tayo ng area, mababawasan yung naging net na yung area natin, mababawasan yung area. So, ano yung tsura nun? Halimbawa, ito yung section ulit natin. And we have here, ganito. Okay? Then let's say meron tayong dalawang bolt na pinadaan sa kanya. So, ito yung magiging itsura nun. Okay? Nung kanyang perpendicular na area. Mapapansin natin dito na ito na lang yung resisting element natin. Kasi butas na yung portion na ito. Okay? So, itong portion na to, butas na to. Kasi dyan dumaan yung butas ng bolt natin. So, ibig sabihin, ito na lang yung ating existing na width dun sa section natin. Kaya kung halimbawa applied pa din yung loading natin dito na P, so ang magiging net width natin is this one. W net natin. And then we have yung thickness natin dito. Okay? So, pag tinanong kung ano yung width nito, of course, magagaling yan doon sa property ng mga bilog natin. And yung largest o yung dinaanan o yung perpendicular na width na to is what we call as yung diameter ng bolt natin o DB. Okay? So, to get the net area ngayon, what will be our formula? So, ang formula natin ngayon, net is equals to yung total net natin, yung original na width natin, minus kung ilan yung number ng butas natin. So, tawagin natin number of bar times diameter of bar. So, ayan yung ating net width. Okay? And then, kapag pinapakuha yung net area, that is just W net times yung thickness natin. So, we have W minus NB dB times thickness. So, that is WT minus NB dB T. And then, papansin nyo yung WT dito, it is what we call yung gross area natin. So, kaya pwede natin substitute dito for area net. That is equals to AG minus yung NB dB T. Okay? So, na-relate natin na ngayon yung gross area with our net area. So, this area equation for net is again, applicable lang siya for dito muna sa plate natin. Kapag naging other shapes na siya, may other consideration na tayo for that. And yun yung di-discuss natin doon sa succeeding slides natin. Okay? So, again, this is cross section and that section. So, gross section, net section, and then gross area. Ito yung gross area, yung perpendicular area, and then net area natin. Okay? Next, since ang goal of our subject is to get yung capacity ng section natin, the code specifies limit state kung paano natin kakalculate yung mga capacity ng section natin. So according to NSCP 2015 section 504.2, ito daw yung tensile strength o the tensile capacity ng member natin. So sa design tensile strength, okay, pag sinabing design tensile strength, as you can see may phi dito, so that is LRFD. And then allowable tensile strength, so over omega, so ASD yan, ang tension member shall be the lower value. Okay? So naka-specify, no? The lower value obtained according to the limit state of either tension yielding of the cross-section or tensile rupture in the net section. So, bakit kaya lower value yung pinapakuha niya? Again, limit state ito, ano? Kung halimbawa nakuha na natin yung capacity natin dito, tsaka capacity natin dito, ang ayaw natin, ma-reach yung limit state natin. Kaya ang gusto natin, yung mas lower sa kanila yung kukonsider natin para pag na-attain yung lower value na yun, bagsak na siya dun sa limit state natin. And yun yung gusto natin iwasan na mangyari dun sa section natin. Okay? So, ayan, we have tension yielding in the gross section. So, we can represent it as gross section yielding or GSY. And then tensile rupture in the net section or net section rupture. Ang designation natin sa kanya. Okay? So, unahin muna natin yung tension yielding in the gross section. For tension yielding in the gross section, the code also specify the following. So, item number 1, when the limit state is general yielding of the gross section, over the member length, the nominal strength may be expressed as Pn is equals to Fyag. As you can see, familiar yung formula natin. That is derived from our formula for stress, which is P over A. And then we will just cross multiply this one and get yung P natin. Kaya meron tayong P is equals to Fyag. Okay? So ngayon, the question is, bakit Fy lang yung ginagamit ni code? Sabi natin, di ba, si steel material can withstand even hanggang maging ano na siya, no? Ultimate, ma-reach na yung ultimate strength niya. Pero bakit Fy yung ginagamit dito, yung pinapagamit ni code doon sa gross section natin? Again, doon sa gross section natin, ito yung gross section natin, itong portion kung saan nandun tayo sa body ng section natin. Ang sabi ni code, pag dito yung member natin, ayaw niyang umabot hanggang dun sa ultimate strength, hanggang yield strength lang yung capacity niya. And ano ba meron sa yield strength? As we mentioned dun sa first lecture natin o sa first module natin, kapag yielding yung pinag-uusapan natin, that is the time na nagkakameron na ng permanent deformation yung structure natin. So, let's say for example, yung mismong member natin na dinidesign, na tension member, is part of a bracing system. And kung halimbawa, inalaw mo siyang mag-exceed ng Fy, pwedeng mangyari dun sa section natin is magkameron ng permanent deformation. So, i-straighten up lang natin to. Permanent deformation. And yun yung ayaw natin mangyari. Kung halimbawa yung bracing natin, ayaw natin maging ganyan yung bracing natin. Exaggerated lang po yan, ha? So, ayaw natin magkameron siya ng permanent deformation. Kaya sabi ni code, i-limit lang natin sa Fy para maiwasan natin na magkameron siya ng permanent deformation. Yun yung sa body niya. Okay? Kaya ito yung gusto niyang maging formula natin. Pn is equals to Fy times Ag. Okay? So, Fy, dependent on the type ng steel, maybe A36, A572, or A992. Maalin po doon is okay. And then, times Ag, yung gross area natin. As you can see, I've also noted here yung gagamitin nating resistance factor for LRFD, that is 0.9 kapag yielding. And then, ang ating safety factor for ASD, that is 1.67. Okay? Next, for tension rupture in the net section. Okay? So, kapag naman yung limit state is a localized yielding, resulting in a fracture through the effective net area ng tension member natin having holes, the nominal strength daw is given as follow. Yan. So, ngayon, ang gusto naman niya, FU, no? Mapaabot hanggang FU. Kasi paano bang nangyayari dun sa mismong, ano natin, bawa ito yung section natin, meron tayo ditong mga butas, ano? And then, kapag nag-rupture siya, so pwedeng ganito yung maging failure niya, no? Pero ina-assume ni code na pwede siyang magamit hanggang hindi pa siya totally napupunit doon sa section natin. Okay? So, halimbawa, paunti-unti pa lang siyang napupunit, ina-assume niya na usable pa din siya. Okay? Kasi yun yung ano natin, ina-allow natin mag-plasticize yung portion nung sa net section natin, no sa mismong bolted area natin. So kaya inallow niya ng FU. Pero ngayon may multiplier siya na AE. Bago yung AE, ano? That is effective net area or U times AN. So yung discussion nito will be a separate module. So meron tayong factor na U, yung reduction coefficient natin, which will be treated on the succeeding video. Pero ngayon, focus muna tayo sa net area and gross area. And then, we have here yung resistance factor natin for LRFD is 0.75. and ang safety factor natin for ASD is 2.0. Okay? So, after we calculate yung mga values na yan, tsaka natin i-compare yung dalawa with each other. Okay? Okay. So, to apply first yung knowledge natin about gross area, net area, let's have this discussion muna. So, in general, for bolted connection, net area is equals to AG minus area loss due to bolt holes. So, bakit sa bolted connections lang tayo ng net area? Kasi sa bolted connection lang or riveted connection lang tayo nagbubutas doon sa plate sa member natin. Kasi pag welding yung connection natin, we don't need to make butas, to butasan yung plate natin. Kaya net areas ay applicable lang para doon sa bolt connections natin. Okay? And when dealing with net areas, there are three important quantities for AN. These are gross area, yung thickness, and effective hole diameter. Now, for gross area, so AG, so as we discussed earlier, it can be calculated dun sa mismong cross-sectional area natin, basta perpendicular dun sa loading, or either dun sa manual. Okay? Kukunin natin sa manual. Later may demonstrations tayo for that. And then next is yung thickness ng plate. Okay? So, yung thickness of plate na mention dito is kung saan nandun yung butas. So, let's say we are calculating the net area ng galing sa AC section. Let's say ito yung C section natin. Okay? And then ito yung three-dimensional na itsura niya, no? Okay? So, let's say may bolts tayo dun sa ibabaw niya. Okay? Okay? Kung nasan yung butas o yung hole na kinoconsider natin, yun yung plate, yung thickness na gagamitin natin. So, dito, sa flange tayo nung C-shape, nagbutas. So, dapat, ang kukunin natin is yung thickness nung flange natin, whatever is the shape of that. Okay? So, let's say we have a bolts dun sa web naman ng C-shape natin. So, definitely yung thickness na gagamitin natin should be yung thickness ng web natin. Okay? So, that is the case for the thickness. Basta, thickness ng plate, it means pertaining, so whatever yung kung saan yung butas na kinoconsider natin. Okay? And then lastly, yung effective hole diameter. So, this is the first time na we hear yung effective hole diameter. So, when dealing with net areas, may tatlong type kasi ng diameter to consider. And effective hole diameter dapat yung gagamitin natin. So, let us differentiate ngayon. So, according to ASC Steel Construction Manual, okay, J3.3, okay, so meron siyang nominal hole dimension. So, yung unang i-consider nating diameter ng diameter is yung tatawag nating bolt diameter. Okay? Or DB. It means this is the diameter mismo nung bolt na gagamitin natin pagbutas. Okay? So, DB yung gagamitin natin. So, for DB, whatever is given on the problem, yun yung gagamitin natin. Okay? Then for number 2, we have yung tatawag nating hole diameter or D sub H, DH. Okay? So, pagdating kay D sub H, in metric, ito yung pwede natin gawing reference sa kanya. So, whatever is the bolt diameter, makukuha natin yung hole dimension natin, yung DH natin, using yung second column. So, sa standard lang tayo. So, halimbawa, given sa atin is diameter 20. So, ang hole na gagamitin natin is 22. Okay? Bakit nagkameron ng adjustment? Kasi di ba pag halimbawa, meron tayong diameter ng bolt, tapos gusto natin siyang ipasok doon sa butas ng plate, pag saktong-sakto lang yung diameter natin, medyo mahirap siyang ipasok. Kailangan pwersahin natin yung bolt para pumasok siya exactly doon sa mismong plate natin. Or pwedeng magkameron ng friction between our body ng bolt natin and yung circumference nung hole na papasukan ng bolt. Okay? Kaya sabi ni code, we need to give allowance for that. Kaya nagkameron ng adjustment na mga values dito. Okay? So, for bolts na less than 22 mm, so ito yun, for DB, less than or equal sa 22 mm, pwede magkameron tayo ng formula. Ang formula for DH is equals to DB plus 2 mm. Okay? So, yan yung kukonsider natin. kapag ito yung diameter ng bolts natin. And kapag hindi na yan yung diameter ng bolts, for dB greater than 22 mm, use DH as per table J3.3 na ang gagamitin natin. So, kasi halimbawa, naging 27 na siya, so 30 na po yung gagamitin natin. So, that is the case for metric natin. Ito yung para sa SI. Okay? For English system, medyo mas madali sa English system. Kasi nagkameron ng conversion kaya iba yung values natin. Ngayon, for English system, yung DH natin can be equals to dB plus 1/16 inch lang. Okay? So kahit anong diameter ng hole kapag English, plus 1/16 ng inch ka lang. Okay? As easy as that. So that is for English. Yung sa SI, since nag-convert nga, nagkameron ng discrepancy kung 2 or 3 yung i-add. Pero we need to be consistent. Kaya kung hindi ka sure kung anong i-add, look at the table. And you can see whatever is the diameter ng bolt, nandito yun sa standard hole diameter natin. Okay? So, this is the first two type of bolt diameter natin. The last is yung tatawag natin effective diameter. And according to the code, in computing for the net area for tension and shear, yung width daw ng bolt hole shall be taken 2 mm greater pa daw than the nominal dimension ng hole. Okay? So, 2 mm greater dun sa diameter ng hole. So, 2 mm greater. Bakit? Kasi di ba kapag halimbawa pinunch na natin yung plate, okay? Nag-punch tayo ng plate, may butas na siya. Since pinersa natin yung pagbutas dyan, syempre kailangan ng pwersa. Makikita na portions of the plate are cracking dahil dun sa force na ginamit pag punch sa kanya. Okay? So to consider the possible effect of these cracks dun sa mismong capacity ng section natin, sabi niya, mag-add pa tayo ng additional allowance sa kanya. Another 2 mm or in English, another 1/16. Okay? So another 1/16 ng inch. Okay? So, kaya dun sa natin, yung pangatlo natin, that is effective bolt diameter. Ito yung kailangan natin, o D sub E. So, D sub E is equals to yung diameter ng hole daw plus 2 mm or yung diameter ng hole, pagbabalik natin yung dB, so dB plus 4 mm tayo. This is for SI. Pero kapag English yung pinag-uusapan natin, D sub E is equals to DH plus 1/16 inch. Pero since yung sa DH natin do sa previous slide is naka plus 1/16 na siya, so plus another 1/16, yung magiging effective bolt diameter natin will be equals to dB plus 1/8 of an inch. So that is for English. Ito yung gagamitin natin for English. So yan yung sinasabi ni code. So dapat tama yung value natin ng D sub E sa nagagamitin. Again, be careful in reading the problem. The problem might say dimension o diameter ng hole. If diameter ng hole lang given sa problem, you just need to add 2 mm or 1/16. Okay? Pero pag diameter ng bolt, you need to add 4 mm or 1/8 kapag English. Okay? So, be careful with that. Okay? So, let's have an example in calculating our net area. So, let's say this is the plate and let's say meron siya ditong break line. Okay? So, break line, ibig sabihin, itong section natin is continuous pa siya dun sa portion kung saan may break line. Okay? So, kung may tensile forces tayo, halimbawa, dito yung tensile force natin, galing dun sa section natin. Okay? So, kailangan hanapin natin yung net area nung section na nagre-resist dun sa mismong section natin. So, dalawa yun. Yung isang area is yung gross section natin. Ito yun, which is perpendicular dun sa loading natin. Or, yung other one, which is galing sa net section natin. Okay? Ito yan. So, lagay lang natin. This section is our gross section. And this section is our net section. So, ayan. So, pinapakuha sa atin 200 mm and 10 mm thick. So, pag pinadrawing ulit sa atin yan, this will be like this, ano? So, ito yung plate. And then, halimbawa, ito yung butas natin. Ayan, i-move lang natin ng konti. Yeah. Okay? So, for gross section, ito yung gross section natin. Okay? So, this is 200. This is yung thickness natin, which is 10. Okay? And para dun sa net naman natin, okay? So, halimbawa, nandun tayo sa net section. Okay? Again, yung ating usable area na lang is ito. Okay? And then, ano yung magiging ano natin? This is net width. So, net width, hindi pa natin alam value, no? And then, ito yung thickness natin. And then, alam natin na ito, ngayon, hindi na siya basta diameter lang ng bolt. D sub E na yung gagamitin natin sa kanya. Okay? So, ngayon, 20 mm bolts yung gagamitin natin. So, pinapahanap sa atin ngayon yung net area. Okay? So, again, according to sa equation, net area is equals to sa AG minus number ng bolts, diameter effective times thickness natin. Okay? Again, yung diameter dito naging effective na siya. So, looking at the equation, kailangan muna natin, syempre una is yung gross area o yung AG natin. According dito sa net section natin. So, for gross area, that is just W times T or 200 mm times 10 mm. So, that is 2,000 mm squared. Okay? So, okay na tayo dyan. Next, kailangan natin yung number ng bolts. Okay? So, later na natin kunin yun. Yung effective diameter muna tayo. Okay? So, next is effective bolt diameter. Yung D sub E. D sub E, since 20 mm yung given, so, ibig sabihin, plus 2 yung gagamitin natin. And then, plus another 2 para sa allowance. So, that is dB plus 4 mm. So, that is 20 mm plus 4 mm is equals to 24 mm. That is our D sub E. Ngayon yung thickness is the same. Okay? So, para makuha yung net area, hindi na natin kunin, net area, AN. So, AN will now be, gross area natin is 2,000 mm squared minus number ng bolts. So, ito yung tatamaan niya, 1, 2. So, NB natin is equals to 2, yung tatamaan niya. So, that is 2 times yung diameter effective natin at 24 mm. And then, yung ating thickness na 10 mm. So, for this plate, ang AN natin is given as 2,000. Okay? So, that is 2,000 minus 2 times 24 times 10. That is 1,520 mm squared. And that will be our net area for this section. Okay? So, ganyan po kinukuha yung net section o net area kapag ganyan yung arrangement natin. Okay? Okay. So, let's have another problem to demonstrate pa kung paano kinakalculate yung net area. Let's say we have this one. Compute yung AN for a W10 by 49 as shown. A 20 mm diameter bolts are used. Okay? So as you can see, we have a W section ngayon. And then ito yung connection niya. So we have connection in the top and sa bottom nung nung mismong W shape natin. So ngayon kung halimbawa, ito yung brake line niya, no? Andito yung loading natin. Alin-alin yung mga magre-resist nung nung load natin. Halimbawa, ito yung load natin. Dito natin i-apply yung load. So, ang magre-resist sa kanya na areas are itong portion na to. Okay? So, bababa yan, ano? Ayan, yung portion na yan. So, ilan yung mababawas sa kanya na area ngayon? Yun yung goal natin. Okay? Again, ang formula natin is AN is equals to AG minus number ng bolts, effective diameter, and yung thickness natin. So, una muna is yung gross area o yung AG natin. Since hindi siya katulad ng plate na width times thickness lang, kailangan tingnan natin yung property ni W10 by 49. Okay? So, punta tayo sa W shape section. Okay? So, this is an example of a W shape table. Okay? So, as you can see sa table natin, may mga iba't ibang properties yung table natin. And when you look at sa shape natin, we have yung pangalan ng shape. And then, as you can see on the second column ng table, we have yung area. So, kapag dito, halimbawa, W12 yung nakalagay, yung nasa ilalim niya na walang nakalagay na word, it means W12 din yung section natin. Okay? So, ang ano natin is W10 by 49. So, W10 by 49 is this one. Okay? Lagyan natin ng W10 by 49. Okay. So, ito, W10 by 49. Yan yung need natin na details. No? And then, makikita nyo, 14.4 yung kanyang area, yung age niya. So, yan yung gagamitin natin, 14.4. So, going back dito, we have 14.4, yung age niya, inches squared. So, convert lang natin sa mm. Again, ang gagamitin natin ng conversion for simplicity is 25 mm lang, ang 1 inch. Okay? So, 1 inch, 25 mm squared. So, ang age natin in mm squared is 14.4 times 25. That is 9,000 mm squared. Okay? Yan yung age natin. And then, number ng bolts. So, ang NB natin ngayon is itong bolt na to, itong bolt na to, itong bolt na to, tsaka yung isa pa doon sa kabila. Okay? So, in total, that is 4 bolts. Okay? Effective diameter tayo. Diameter. So, yun, D sub E natin. So, again, 20 mm tayo. So, that is DB plus 4 mm. So, that is 24 mm again. And then, yung thickness natin. Anong thickness ngayon? Since yung bolt natin is bubutas tayo ay sa flange nung ating section. Okay, ito yun. So, ito yung kailangan natin thickness. Yung thickness nung ating flange. And then, saan natin kukunin yun? Ibig sabihin, sa table pa din. Pabalik tayo doon sa table. Okay? So, thickness ng flange is equals to, ito yung table natin. Okay? And then, ito yung thickness natin ng flange, thickness ng web. So, be careful which column yung titingnan. So, thickness ng flange yung kailangan natin. So, ibig sabihin, so, thickness ng flange, so, ito, no? 0.56. Okay? So, 0.56 inch yung kanyang thickness. So, we have 0.56 inch times natin sa 25 mm, 1 inch. So, that is equal to 0.56 times 25. That is 14 mm. Okay? So, para makuha yung net area na AN, so AN is equals to AG natin is 9,000 minus number ng bolt, that is 4. Effective diameter is 24. Then thickness is 14. So, we have that is 7,656 mm squared. Yan yung net area natin. Okay? So, that is how you calculate the net area for a W shape or a hot rolled section. So, kinoconsider natin kung ano yung thickness kung saan siya nakakonect. Okay? So, kung halimbawa, yung web natin, meron din siyang mga bolt dito. So, kasama siya sa bilang. Pero, iba po yung magiging thickness nung sa web natin. Okay? Alright, so, that's it for gross area and net area. So if you have question, please leave a comment. Okay, and then I'll see you guys again on the next lecture. Thank you.